This is a demo of the latest example code for the 5-axis routing. The example demonstrates cutting 4 different passes at 4 different angles so that each side of surfaces get coverage. And I will just run. The code will need explanation, but the demonstration shows a mesh as a surface with slight curvature and some cube shapes hovering above them. When I run the code, the first thing that it's going to do is map the scene, and it creates basically a map, a curved set of points, and then it profiles the points and it simulates the geometry of the router using 2 squares. One is the housing of the router, and then one is the tool tip. So you can see as it does each pass along the surface, it's checking for collisions and pulling the router back. Well, that's not good. So in this example, it's coming in from one angle. So you can see the line here is the surface profile. So it's mapping points along the surface detected, and now it's showing the tool path, which is based off of the surface, but you can see along the profile, along the edges, it's expanding the region so that the machine doesn't collide with the part. So once it runs through its iterations to remove the collisions, then it will demonstrate the final cutting pass. There we go. This is the final cutting pass. It's running through this pattern. So you can see the angle of the BC, and the surface coverage will be on this side, and then the mesh. So you can see in the regions where the tooltip can't get, it pulls back, and then it'll let another routing pass get that area. So let's do a different one. Same mesh, but this time we're just cutting it from a different angle. So it maps the surface. Once it maps and looks for initial collisions, it's going to generate a tool path, and then it's going to modify the tool path to remove all of the collisions. So it's looking at both the tool tip and the housing of the router. You can see at the base here it's expanding. Looks like it's got it there. So now it's running through the cutting path that it generated. So you can see the profile that the path is cutting is the mesh surface here, and then this side of the surfaces. So this surface, as well as the top. Now, cutting from 4 different directions, there's going to be duplicate surface cutting, but at least it will cover most of the surfaces that the machine can access. When it's done, it's going to print out example G code, which includes the X, Y, Z, B, and C for the direction, and the actual coordinates are not exact because these coordinates are offset by the geometry of the machine, specifically the length between the tooltip and the axis that the B and C rotate, which is just random for the example. I'll do another demo from a different angle. So it's mapping from a different angle, checking for initial collisions, and then it will generate a toolpath. So when the toolpath is ready, it hides the mapping. Now you can see it's going to be expanding the region of the cutting path. Hopefully this isn't too fast to see the changes that it's making. And then when it's done, it's going to run through the toolpath. So you can see the features being cut are on this side. You can see the lines here, these edges right on this surface and on the top. Now that it's done, it's going to run through the toolpath and you can see it from the different angles. So anytime it gets to a spot where it can't get the tool in, it pulls back on the axis that the tooltip is pointing based on the B and C axis. It doesn't necessarily need to run these jagged edges. This is just a demonstration or a prototype concept. This would, on the machine, would just be extra movement in the air, but it's safe because at least this area up in space is known to be non-colliding. So this is a representation of the machine. So this is the housing, and then this is the tool tip that's used as a collision. So the one thing that this example doesn't do is it doesn't take into account the geometry of the milling bit or the drill bit. So the roughing bits are flat and some of the finishing bits are ball nose or round. Some of them could be different geometry. So a way of compensating the profile could include moving the location so that the surface matches the correct area on the scene. And then there's also extra checks that will need to be done for the collisions because the width of the drill bit will also have different points that need to be checked for collisions. And the code I will have to explain separately, but this is just a demonstration of the example code.